creating a scatter plot with just 4 points. So you want to put those in your scatter plot. Now you have data in your scatter plot probably right now that you don't want to ditch yet, right? You guys are still working with that data from the Tootsie Pop activity. So let's use other lists. You can always do that. So I'm going to go to Stat Edit. You guys have stuff in lists 1 and 2 already. How about we go over to lists 4 and 5? So I'm going to go to 4 and 5. And I'm going to enter the X's of these 4 points in list 4. And I'm going to enter the Y's in list 5. And I better go into my scatter plot and tell it what lists to use, right? And you should be following along with me if you're not. I'm sorry, this is washed a little bit. Yeah, you can go grab one off my desk if you want. Okay. And we want to make sure it's doing a scatter plot with list 4 as X and list 5 as Y. And we're going to press zoom what? Of course, zoom 9. And we get our scatter plot. So you can see there's 4 points. They're fairly evenly spread out, right? It looks like what kind of shape? A parallelogram. Yeah, totally. It looks like a parallelogram. So now we're going to want to add another point and see what it does to the model. So let's go ahead and compute the model first. So let's calculate that. How do I do that again? Remind me. Stat, calculate, linear regression, right? That's what you guys were just using. So if I hit enter now, it's going to tell me error because it thinks I'm telling it list 1 and list 2, right? Which I don't have anything in. So what should I have done? I should have pressed linear regression list 4, comma, list 5. If you have that menu pop down thing, I mean, it's even easier to not make that mistake. That's why they made it. Okay, so there's our linear regression model. So we've got y hat equals 0.4x plus 2.8. This is like the first time we've been working with a set of data that is contextless for like this whole unit, right? We always have context. This is the first time it's just about the raw data. The calculator got a 0.316 strength, which kind of makes sense, right? It was like a parallelogram. It should have a weak strength. Did it look like it had a positive strength? I mean, here's the picture of it again. Yeah, it looks positive, so that kind of makes sense. Does it look linear? I don't even think there's enough data to tell, you know what I'm saying? There's not enough data. The whole point of this activity is to see the influence that just one other point can have. And we're going to have that other point wander about and see what it does to the model and to the correlation. So the first other point we want to add is 3, 4. So you guys have enough to fill in this blank right here. So you've got the slope, you've got the correlation, and now we're going to add 3, 4. Let's see what happens. So 3, 4. So 3, 4 is that point right in the middle. You guys see it? What do you guys think? Is that going to make the correlation stronger, weaker? Stronger, you think, Carson? Okay. It certainly doesn't depart from the overall trend, right? When we're in this chapter on regression, we want to be thinking about the overall trend and the influence that certain points have on it is what we're looking at today. So let's recalculate. So was Carson correct? You've got the next thing to fill out your second row there, right? And the new R is, oh man, it's the same. Crazy. Did our actual line even change at all? It didn't change at all. I think that's because that point is actually perfectly on our line. Let's see what happens when we change it to 8, 6. That's what we're supposed to do now. So same stuff for those first 2 rows in your table. So let's go delete that point. Change it to 8. That's farther away in the x direction and 6 in the y. I forgot to press zoom 9 because it's off the edge. Very good. There we go. So it was added to the right now. So what do you guys think? Is that going to make the correlation stronger? Is it going to affect the line? Well, yeah, it's definitely going to affect the line this time, because before it was like trying to go right in the middle. Now it's going to be pulled more that way. You guys know what I mean? So we know it's going to affect the line. You guys think it's going to make it stronger, weaker, about the same? You think stronger, John? Let's find out. This is all about investigating today. Actually, I'm just going to turn this projector off. Making these things work together in this class is just oh so fun. So you guys can feed me the rest of those. So, did it make it stronger? Yep. John was correct. 0.5 now, right? Did it change the A and the B? It didn't. I thought it was going to change them. Let's go back to our scatter plot. I thought it was going to change them. What's the only way that it isn't going to change them, Carson? If it falls on the line, just like the first one. Awesome. Nice. So let's add another one. What's the next one they wanted us to add? So we added, that was 8.6. What's the next one? I'm going to write down our original just so we have it for comparison up here. Next is which one? 10.7. Thanks. Whoever else. So 10.7. That's even more extreme. I bet that'll affect it even more. You guys know what I'm saying? Let's calculate. Just 4. I keep wanting to just press enter there. It's so sneaky. It made it stronger. I guess I should go back and zoom 9 it and look at it first, right? I think, does it make sense that that's going to make it even stronger? Can you see a stronger linear shape now, just because that moved out a little bit further? And is it going to affect the model? Well, it depends if it's on the line, like Carson said. I didn't think that other one was, but I was apparently wrong. So, going back to my calculation. This is getting annoying. Maybe a bad choice. Yes, it did. It must be a little bit off the line. It's almost the same though, right? Still close to a 0.4 slope and still close to 2.8 for the intercepts. This one must be just slightly off what the line was to begin with. Does that make sense to you guys? All right, what's the next point we want to add? Is that the last one? 3.8? Okay, what are the other ones? Let me do them.
1.7, 8.9.
Okay. So I'm going to go through these a little more quickly. If you're watching the video, you just want to look at my models as I go. So let's see, stat edit. We'll do one more together, and then I think I'm going to let you guys go a little bit. Fill that out yourself for a second. So 3.8. That's a different spot. That's higher now. So how's that going to affect the line? What do you guys think? If that's up here, you want to actually think about grabbing the line and where it's going to go. It was like this, right? Now it's going to be pulled and influenced up that way. What's that going to do to the correlation? I think it might make it weaker. Isn't it like more of a random scatter now? I think so. Let's see what happens though. It's hard to say when you just have this many points. So let's see what happens. Yep, weaker. Haha, I knew it was more randomly scattered. And you can see that the slope didn't change, but the y-intercept definitely did. So it just like pulled it up. It just slid the line up. Does that make sense? All right. Why don't you guys go ahead and look at the effects of 1.7, 8.9, and 10.0, and then we'll come back together in a second. So I'll let you calculate all those models yourself, and we'll get back together in like 5. Okay, so here's what you should have gotten for yours. I still want to talk about the residuals. We haven't talked about that yet. Let's start by talking about the residuals for that one of that first points. This was actually like up farther in your chart. Sorry, I didn't have room at my board. So this is one of the first ones we did. It was the one that surprised me, right? The one that Carson helped us out with. It was the one that fell on the line. So if the point is actually on your regression line, what's the residual? Remember, the residual, which you should have locked and loaded in your mind right now from last week, is that the residual is the actual thing, or the real y, minus the predicted thing that comes from your model. So if it's actually on the line, the residual has to be 0. So anything that was on the line that we added, those first two were actually on the line, they should have a residual of 0. The next one, 10.7, if you remember, was just slightly off the line. It didn't change the slope very much. It changed R a whole lot because it added shape to the graph. And we're going to go over that again with another example here in a second. So it made R really different, but it was real close to the line, so it didn't change the slope. If it's real close to the line, what's its residual? Not very much, so small. Now you guys looked at some of these other ones. 3.8 supposedly has a large residual. Let's look at that one again. So I'm going to go back and investigate 3.8. Oh, I've got it in there already, so zoom 9. 3.8 has a large residual because here's the regression line. For 3.8, let me calculate it again. My regression line is 0.4x plus 3.6. 0.4x plus 3.6. Clearly there's a very large difference or discrepancy between the predicted value for that x and the real value for that x. It's very far away from the line. Even though it's very far away from the line, did it change the slope? No, it didn't even change it at all. So just because something's far away from a line, does that make it, and the key word for today, if there are word of the day, is influential. You started the Chapter 9 reading guide, as I saw several people had. You should be encountering this word, influential, which is uber important in statistics. So, is this point influential just because it's far away from the line? The answer is no, it didn't even affect the slope. Did it affect how good a model it is? Well, sure. This is way more spread out than it was when it wasn't there. Does that make sense? Some of those other points, though, definitely did affect the model. That's what it means to be influential. But a lot of students in statistics think, oh, if it's far away from the overall pattern, that means it's automatically influential. Clearly far away from the pattern, but not necessarily influential. This is a point you'll see in your reading guide tonight, but is not high leverage. Okay. Let's look at one of these points that did have high leverage. So let's go look at one of the other ones. From our table there, which one really changed the slope of the model, really changed the line? 1.7 really changed it, right? Yes, it in fact changed the slope from positive to negative. So let's look at that one. That one must be influential. Let's see why. 1.7. So zoom 9. I have my old model on there now, right? I should get rid of that. Let's clear that out. So here's our model again. This point is also far away from the line. If you think back to the line from a second ago, we'll put it back on there. It's also messing up the pattern. But see, now, because there's only 3 here, it even suggests that maybe the pattern goes this way. That's an extremely influential point. In fact, the model that you get from it when you run regression is totally, totally different. Now it's about negative 0.06x plus 4.75. Let's see what that looks like. Yeah, that's now the least squares best fit. It completely changed the entire ball game. Now this is a small ball game. We've only got a few points. So does that mean only small ball games can be influenced by such influential outliers as this one? Well, let's talk more about that. But you guys get the point here, right? Let's finish this guy first before I talk more about that. What does question 3 ask you to do? Question 3 says, a point that dramatically changes the apparent slope is called oh, they're just repeating me. You need to be able to spot influential points. What should you look for? Things that significantly change the slope/y-intercept. That's as simple as it is. The book's answer is this. I'll read it just for anyone interested. The book said, to spot influential points on a scatter plot, look for points that depart from the overall pattern. Well, duh. Especially those points that are outliers in the x direction. That's what I just talked about. Because that one that was a big outlier in the y direction, did it do anything? It made r smaller, that's all it did. It says, do not necessarily look for points with large residuals. Influential points change the slope, so they often have small residuals. And then the last question says, originally there were 4 points here. Suppose that instead we started with 50, and they were about, clustered in the same region, displaying about the same kind of association. Would the 51st point still be as influential? And where would it have to be as influential? What do you guys think? Would 1 point change a pattern of 54 as much as it did 4? No. But, well, it could. What do you mean, Rick? Very good.
Depending on where the point is, it can change it really fast.
But
it says that they're all like inside that same area. So if it is up and like far to the left like that, it might change it to the
yes, so that's what we want to think about. That's what's in Chapter 8. This is higher level regression than like Algebra 1 or Algebra 2. That's why Chapter 9's title is Regression Wisdom. So, they assumed like there were a whole bunch of points all in the same region, right? So if we had a whole lot more points in the same region, instead of just, those 4, if we come and put a point like right here as our new wandering point, it's going to change the model a little bit, but not very much, right? Like you're still going to have a model that goes like this. But Ricky said it could still be majorly influential. In what case? That's what you guys are talking about. Where would I have to put that blue point? Instead of there, it could be majorly influential in a few situations. If you put it like here, there, or even down here, I don't think it's going to do a whole lot. There's a few places you can really make it do a whole lot, though, which is what you really got to look out for in real data. What if I put it up there?
And make the association stronger.
Much stronger, exactly. So I think that's what Ricky was trying to point out to begin with. It would just have to be farther away, kind of in the same direction. It could be up there. That would make the association that exists there already really stronger. If I put it down here, it's going to make that same blue association really stronger. What if I put it over here? That blue association is like totally wrong now. So you've got to be really careful when doing scatter plots and working with bivariate data for looking out for influential points like these. That green guy, just because he's one guy, does he like determine the whole trend of what's happening here? No. It's extremely influential though. So if you just go into a scatter plot and you're like, entering my scatter plot, calculating my model, using it for things, and there's influential things in there, like for instance, if you were typing in your data and you missed a digit, it's going to not mess you up a little bit. It possibly could do what the green guy's going to do and really mess you up. You see what I'm saying? And there are influential points like that in data. So that's my main thing I wanted to talk about for today. All right, you guys have still like 10, 15 minutes. You can work on your Tootsie Pop thing or your reading guide or your problems. So.